Okay, today's CSES question is called distinct values subsequences. So given an array of n integers, count the number of subsequences where each element is distinct. A subsequence is a sequence of array elements from left to right that may have gaps. Okay, so the only difference from this question from the last one is that this one allows subsequence, whereas the last one was subarray. Subarray means it has to be continuous, whereas subsequence you're allowed gaps. So that's the only difference. And that changes our approach, right? So what we have to do is our answer can be large, so we have to modulo it by 1e9 plus 7. And then we can think of it as these are the following like possibilities. So then broken down, this can just be the mathematical formula. Like we can just think about counting the number of elements of each one. So for instance, here I have two ones, 1, 2, and 1, 3. So then the number of ways that I can work around this, that I can make different combinations would be 2 plus 1, which is 3. 1 plus 1 is 2, 1 plus 1 is 2. So that I would have 3 times 2 times 2, which is 12, and then I would minus 1. Why is that the case? Because I can just write something as like having how many choices inside each one. Like, because let me go to a whiteboard actually. Let me go to like just a section so that I draw it out, and I'll share the screen with you before. Um, Let me see how I can share my screen. I'm not sure if this is sharing, but um, yeah, let me share the screen instead first, so that it would make more sense. So the idea is that we would first count the things. So for instance, here we would have, get my marker. We would have something like how many numbers of one, how many twos, how many threes, so on and so forth. And then inside this group, let's call this, let's say, count one, C1, C2, C3. So then what we can do is essentially how many ones there are. We could either pick 0, 1, 2, 3, 4, 5, up to the C, right? So then we would have C1 plus 1 choices. And then for C2, we would have C2 plus 1 choices because 0 is also included, right? So for everything, we would just have that number, how many of that number there are, times plus 1. And then it would be the product because each one is kind of can be treated independently. How many I pick from this doesn't matter from that. So it would just be the product. So essentially what I'm trying to find is just the product of um, the count plus 1. So that would be what I have. And then obviously because the last case of just like the trivial case of all zeros don't count because I have to pick something, then I would just have this minus 1 at the end. And that would be what I would find. So how I would approach this is just sort the array, see how many of the count I have, and then have a product of it and make sure that I have a modulo of that, whatever, that 1e9 plus something 7 or something like that. Basically keep that number. Let me share my screen back to the two things I had earlier. No, wait, it's not sharing. Don't want to share this. Okay, so hopefully you can see my screen now. So how I would approach this question is first I include the libraries I need, then I define long to be LL. Then yeah, I just talked about the product of the count plus the 1, and then in the end minus 1 to take out the 0 case. And then I make my input slightly faster, input output. I get my in and I see in it. Next, I have a vector of integers, which I call A, and I initialize n values inside. Then what I do is I input them, pretty straightforward, and then I would sort it so that like I could keep track of how many I have, right? The less to the more. So then if there was the same element, then it would occur all in one chunk. Then I have my answer that I'm keeping track of, my modulo, so that I make sure I can mod it every time. And I keep count of the current count. So what I do is I just go from left to right. I compare, is my current element the same as the one before? If it's the case, I increment my counter. Otherwise, I would just update my answer to be the answer times the count plus one, and then make sure I modulo it so I don't exceed that. And I reset my counter back to one. So that's pretty straightforward. Otherwise, I just increment my count. So that's just kind of keeping track of what is my current count and just like updating my product. And the end of the thing, it would just be my product. If n is greater than zero, my answer would just be that. My answer is that thing, and I output my answer. I think it's pretty straightforward, this question. Even though it's kind of interesting from the previous one, because even though you might think it's quite similar, but the approach you take is different. Just because inside here we could treat the elements as the same, so then we would just group it together. And then that would just sort of mean that we would have to first sort it, then just count, and then get the product from the count plus one. Guess that's pretty straightforward. End it off here.